my name is Mandlik Prajwal, and I have done BTech from NIT Raipur,
NIT?
and
Which
currently
NIT?
preparing Raipur.
Raipur. Okay. Okay. You're preparing for GATE which subject?
Physics,
Okay. Okay.
GATE and CSIR net.
Acha, acha. Okay. So you have done BTech in physics or
No, sir, no, not from physics.
Okay. 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 Fine. And Rituraj, you are in the first session, I think.
Yes, sir. I was in first session also.
Okay. Okay. And Amit, I
Hello,
didn't.
sir.
Yeah.
My name is Amit, and I have just completed my master's
Mm-hmm.
MSc few months back,
Mm-hmm.
in September.
Okay.
So I'm now preparing for CSI Net and GATE, along with
Mm-hmm.
other exams like TIFR and
Mm-hmm.
JEST, etc. And
Okay.
I want to pursue PhD.
Okay. Okay. All the best. Yeah.
Thank you, sir.
Yeah. And other people like Pandiyaranjan, then please introduce yourself one by one.
Good evening, sir. I am Pandya Rajan. I
Yeah.
completed my MSc
Mm-hmm.
last month. My preparing GATE exam, next GST exam, sir.
Okay. 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 Thank you. And Lupesh. Lupesh. Yeah.
I'm audible.
Yeah. 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 You are audible. You can introduce yourself.
I'm Rupesh Kumar. I'm MSc passed out student last year from NIT Durgapur.
Mm-hmm.
Now basically I'm preparing for CSIR net and GATE both.
Okay. So you passed recently your MSc?
Yes, last year.
Last year. Okay. Okay.
Yes, sir.
Okay. Fine.
Thanks.
Yeah. Then Aditya. Okay, mic not working. Rajiv, you joined earlier, so I know you. And other people, like who is joining for the first time, please introduce. Like Lupesh already. Suraj, Shodab, Seema. Can you please introduce yourself, guys?
Hi sir.
Hello, hello, sir.
Yeah, Suraj. So, Suraj, you can
Hi sir.
continue.
My name is Suraj.
Yeah.
I'm currently an MSc student at Mahatma Gandhi University, Kerala.
Okay, okay. Okay, so you're pursuing now your MSc or
MSc. Yeah, I'm pursuing my MSc now.
you are in third sem or fourth sem? Third, I think
No,
it
no,
should be
fourth sem.
fourth sem. It should be fourth sem.
Almost in the completion time.
Okay, okay, okay. Yeah, yeah, good. Okay, fine. And short of,
Hello, sir. Myself Saurabh Sinha Mahabatra.
hmm.
I am from West Bengal, Sidhu Kano Birsa University.
Okay, okay,
I am MSc pass out student
okay,
this year, sir.
okay, okay. So you'll be preparing for GATE and CSN NEET. Okay, right?
Yes, sir. Yes.
Okay, fine. Anyone else?
Hello, sir.
Harsh.
Sir,
Yeah.
sir, I am Harsh, and I am preparing for NET, GATE, and other exams.
Mm-hmm.
And I have completed my MSc 3 years ago.
Okay. So since then, what are you doing?
So I am preparing for job-oriented exams also,
Okay,
side by
okay,
side.
okay,
Yes.
okay, okay. Fine. Yeah. And anyone else? I can see someone's joined. That is Shanmuga Priya. Seema. Also, you didn't introduce yourself. Can you please introduce?
Hello, sir.
Yeah, yeah.
I am from West Bengal. I am
Mm-hmm.
doing now BSc course.
Mm-hmm.
So I will prepared for GATE and MSc.
Okay, okay. You are doing your BSc now.
BSc course
Okay, okay, fine. Okay. Okay, I hope
for
this course
physics
will be,
honors.
I understand. I hope this course will be helpful because this is dedicated to totally GATE, I think, but it will be helpful, I think.
Okay, okay.
Yeah.
Okay, sir.
I can see some 1, 2 people who joined recently. Vakashri, Anuj, can you please introduce? Please do it quickly so that we can start.
Good evening, sir. My name is Bhagyashree.
Yeah. You're joining for the
Hello.
first time?
Yeah, yes, sir.
Oh,
Today
okay.
only I joined.
Okay, okay, okay.
Today I get to know about this.
Okay, okay.
I completed my MSc Nuclear Physics in 2020. I
Mm-hmm.
took coaching GATE for 1 year,
Mm-hmm.
but I didn't prepare well.
Okay.
But my first attempt is this year only.
Okay. Okay.
I'm going to.
So you'll be preparing for GATE, NATE also, right?
Yes, sir.
Okay. Okay, fine. Anyone else
Thank
who
you.
didn't introduce? Okay. Please finish your introduction quickly so that I can start with the proper thing. Okay. Okay, so that I don't think so. Anyone else there? Okay.
Sir,
Yeah.
can you please tell us about what is the structure of this course
Okay,
besides
so in the first
information and
session,
development? Yeah.
okay, so already the we have completed the first session. This is the second session. So the motto for this course is basically to discuss the previous year GATE physics questions, so that we in each and every class will be discussing maybe 3 4 I mean, if time permits, maximum 4 questions. We'll discuss thoroughly about if theory is required for that to be discussed, then we'll discuss that. Mostly we'll be discussing the previous year's questions here. Okay, the solutions will be available. The video solutions will be available in the portal also in our private YouTube channel also. It will be available, the solutions, so I can share my YouTube channel also, link also. You can see the previous years, I mean previous sessions videos that is available. This is the main thing, and there is no proper structure of this. The basically there is a doubt clearance class or live session for the gate physics, previous gate physics questions. That's the thing. Is it okay, Harsh?
Okay.
Yeah.
Yes, sir. Thank you.
Okay. Okay. So I am starting now. Okay. Is my screen visible?
Yes, sir.
Okay.
Yes.
Okay. So, okay. So let me introduce myself. I am Bishar Roy. I am pursuing my PhD in experimental condensed matter physics from Department of Physics, ISA, Bangalore. So, and about the course, you already know what I will be doing, that I will be discussing some previous year GATE physics questions. So in this class, I will be discussing some questions from GATE physics 2020. So let me start. Okay, so this is the question from GATE physics 2020 paper. There is a MCQ type question, and the topic of the question is electromagnetic theory. So let me read the question first. The question is, a medium with epsilon r greater than 1 and mu r equals to 1 and sigma greater than 0 is semi-transparent to an electromagnetic wave when there are 4 options given. So first option is conduction current very greater than displacement current. Option B, conduction current very less than displacement current. Option C, conduction current equals to displacement current. And option D, both condition current and displacement current, conduction current and displacement current should be 0. So it is the MCQ, so the only one option is correct for this question. So first read the question carefully. If you have any doubt or in difficulty in understanding, please ask me. Then you can take some time to solve this question, to attempt this question. And after that, I can discuss the solution. So is the question is okay to everyone?
Yes, sir.
Any difficulty in understanding the question? Okay. Take maximum 5 minutes. There is no hardcore time limit for this because this is a discussion forum. So you can take time, and I want you to solve this question to get the proper answer, correct answer. If you have any doubt, you can ask me in between when you are trying to solve this.
Sir, I have not prepared electromagnetic theory,
Okay.
and I have almost forgotten everything.
Acha.
Matlab, I know,
Who are you? Can you share your name first?
Sir Harsh.
Harsh. Okay. Yeah. Yeah. Please tell me.
So how should I proceed?
For this question you are asking, I mean, as you have forgotten everything, so I mean, this so basically in this question you require to know, have to have the idea about Maxwell's equation. That's the thing. Okay.
Okay, sir.
So if you are not prepared with that chapter, first read the chapter. Okay. Anyway, I'll be discussing the solution. You may recall the thing, but I will suggest you should read the chapter properly.
Okay, sir.
So otherwise it will not be proper way to directly solve the question. So I mean I will expect that at least you know the basics. Okay. Anyway, you can just prepare for with that chapter. Next inform the next classes. I think it will not be difficult for you.
Okay, sir. Thank you, sir.
Yeah. Yeah. Okay. Anyone else? My screen is visible, right?
Yes, sir.
Okay. Okay. Let me know if you get the answer. So can anyone share any idea what to do in this case? I mean, how to proceed with this solution? Anyone?
So I think we have to consider the propagation of EM wave in a medium with these properties given, and recall Maxwell equations in that medium, and then solve this.
Okay. So one thing that is the hint you should pick up from the options, that is you have to deal with only conduction current and displacement current, right? So that is already given in the options. So you have to deal with the two things only. Okay. So first you have to know the expression for conduction current density and displacement current density, or conduction current and displacement current. Anyone can tell me how it is related to electric field, the conduction current? What is the expression for conduction current density?
J dot ds.
J dot ds, that is a total current density, right? No, I am asking how the conduction current density, that is Jc, is related to the electric field. So there should be an equation. So there is a small equation that you should know that what it is. Can anyone tell me that?
J equals to sigma times E.
Yes, that is the conduction current density. Okay, that's good. So, and the second thing, how the displacement current density is related to the electric field. Can anyone please tell me? If you know these two things, you can easily solve this problem.
Epsilon 0 del E del T.
Yes, who is this?
Sir, I am Chaudhary Kamruzzaman.
Okay, okay, fine. So you know both the things. Okay, so now, so what to do next? If you know these things, what to do? And here you can consider a monochromatic electric field vector. That's the thing you can consider here. You don't have to think about I mean superposition of multiple electric field, complex electric field. You can consider a monochromatic electric field. That is plane wave actually. That is E naught vector e to the power I k dot r minus omega t for the electric field expression. That will be simplified in this case. So you know the conduction current density vector and displacement current density vector expression, and consider the electric field is a plane wave equation. So you can simplify the expression for the conduction displacement current density because there is a partial differentiation of electric field, and then from the options you have to take the idea of what you have to do. So I can tell this, you have to take the ratio of both the things, then you have to conclude. So I have given a hint for this. Now Achha, can you tell me what does it mean semi-transparent to an electromagnetic wave? What does it mean? Is it a good conductor or poor conductor? Anyone can try.
Poor conductor.
Yes. Semi-transparent means that is poor conductor. That's a lossy dielectric. If you have read about this dielectric, there's a loss tangent of a dielectric, how it is defined. So I will be discussing little bit, but first take the ratio of JC and JD. Okay, and consider the electric field to be plane wave, so that it will give a expression that is the ratio of JC and JD equals to in terms of sigma, omega, and epsilon. So what's the expression that I want to know from you guys? So JC is, you know, sigma E, JD is epsilon del E del T, E is your E naught vector e to the power I k dot r minus omega t, that is plane wave. Just put that electric field there. So you will get, okay. So what will you get? JD then, if you put that. No one is responding.
A.
You are saying option
A. Yes.
Okay. Okay. Who is this?
Amit.
Amit. Okay. How did you get that? Can you please share? Don't worry if it is wrong or right. Don't worry about that.
I'm actually practicing some other subjects, so I'm not in touch with EMT for now. But
Yeah.
I, from what you have told, I have just tried to do this and then put the values, means what is given, and then I think it is coming out to be less than one value.
That is
Means the
JC
ratio.
by JT is less than 1 you are getting, right?
Yes, yes.
So if you are getting less than 1, then your JC should be less than JT or JC should be greater than JT.
Okay.
Yeah, just check.
Let me check again.
Don't be hurry. Just check. So what did you get, JC by JT? Can you please tell me?
Sigma by j omega.
Sigma by j omega you get. So
Sigma by
you
epsilon
can
naught.
take the modulus of that. You don't have to consider the complex part. I mean j part, that is.
Sigma by omega.
Sigma by omega. There is nothing else. There should be one more
Sigma by
term.
epsilon naught omega.
Sigma by epsilon omega, not epsilon naught, because you can consider not,
Okay.
you are not considering a free space here. So there should be
Yes.
epsilon r. So basically epsilon naught, epsilon r should be there.
Yes. Yes.
Yeah. Okay, fine. So if that is the case, and from the term semi-transparent, you have to consider it as a poor conductor. That you have to know actually. If you have read this dielectric chapter, then you must know this. If it is semi-transparent, that means it is a poor conductor or lossy dielectric. So in that case, this ratio should be very less than 1. Okay. because your conduction part should be very, very less than 1 than the displacement part. So from that you can conclude directly, that is the conduction current is very, very less than your displacement current. Okay, I will be sharing the formal way to solve this question. Anyway, option B is the correct answer for this question, whoever got this. And okay, okay, my screen is visible, right? Hello.
Yes.
Okay.
Yes,
So,
sir.
okay. So, for a linear, homogeneous and isotropic conducting media, we know the Maxwell's equation, that is the fourth, or I think third, yeah, fourth equation, that is curl of H equals to total current density vector, that is the summation of JC, that is conduction current density vector, plus displacement current density vector, that is also known as modified Ampere's law. So, here the conduction current density Jc is written as sigma times your electric field vector, and conduction displacement current density is written as, that is partial differentiation time with respect to time, that is del d del t, that is equals to epsilon times del E del t. Here sigma is the conductivity of your media, epsilon is the permittivity, and E is the electric field. Okay. So, now we will consider a plane wave for our simplification. So, your electric field vector is E naught times e to the power I k dot r minus omega t. Just put it in the expression in of Jc and Jd. So, Jc will give this, and Jd you will get epsilon times del E del t. So, del of t in the Maxwell's equation, it will basically give your minus I omega, that you know. So, you just put it here, and this remaining part will be your electric field. So, you can write it Jd vector equals to minus I omega epsilon electric field vector. Now, take the ratio, modulus of the ratio. So, you will get sigma E, mod of sigma E divided by mod of minus I omega epsilon E vector. So, it will give sigma divided by omega epsilon. Up to this it is clear, right, to everyone? Any difficulty in this? I have already discussed these things. So, when you are trying,
Yes, sir.
yeah, okay. So now everything is very simple, because you know semi-transparent media means it's a poor conductor or lossy dielectric. So for this, it is also known as the loss tangent. So for a semi-transparent media, the loss tangent is very, very less than 1. And sigma by omega epsilon is basically this Jc divided by Jd, that is very, very less than 1. So from here you can conclude mod of Jc very, very less than mod of Jd. So from this you can choose the correct answer, that is conduction current for this semi-transparent medium is very, very less than displacement current, that is option B. So for this question, option B, that is the conduction current very, very less than displacement current, that is the correct answer. Okay, is the solution is clear to everyone? Any doubts or anything? You can please ask me now, otherwise I will go to the next question. I don't think so. No one is responding. So, Amit, is this correct, right? I think you have done it correctly.
Yes, yes.
Okay, 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 fine. So I can go to the next question. Okay. So this is also the question from GATE Physics paper 2020. This is a numerical answer type question having 1 mark. This is also from the electromagnetic theory. So the question is, far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength 4 times 10 to the power 14 ampere meter. Assume this magnetic field is generated by a current carrying loop encircling the magnetic equator. The current required to do so is about 4 times 10 to the power n ampere, where n is an integer. The value of n is, so you have to find the integer value of n. So here one information is given, that is Earth's circumference is 4 times 10 to the power 7 meter. So you have to find the basically the current which can produce the magnetic pole strain this given in the question. So basically from that you
Is it
can
7?
huh
Is it 7?
so how did you do these two first? Do you know the answer, or how
No,
do you
sir.
do?
Just divide both. Unit.
Sorry,
The
sorry.
unit is just divide both.
Divide the both means
4 into 10 power 14 and 4 into 10 power 7.
so you are dividing it by our circumference.
Yes.
So why
Yes,
is
I
it
think he has done dimensionally.
okay? Okay. Uh,
But still, sir, we will get 10 raised to the power 7.
okay.
And
That's a
in answer, we are required to find 4 into 10 to the power n.
hmm. Okay, I'll not tell that what is the correct answer now, because that is not the proper way. Okay, uh, so it's okay. You are just I mean getting it dimensionally correct, but I want to know the proper way and proper concept of this how to solve this question. So
The magnetic field generated by
hmm.
a current carrying loop, we have a formula B equals to mu naught I by twice pi r.
B equals to mu naught I by 2
Pi r.
2 pi r or
I
2.
I don't really remember that formula. Means
Okay, that is mu naught I by 2r, not 2 pi
okay,
r.
okay,
Okay,
okay.
okay. So from that, how can you get that current value? I mean, you are given on the magnetic pole strength. So how is it related to that that current or magnetic field? Can you please tell me? I mean, do you know the definition of magnetic pole strength? How it is related to the magnetic field produced by a current carrying loop?
So it was a ratio. Means I
Hmm.
don't remember
You
the
can try.
actually.
You can try. You can try. If you are wrong, I will tell you. No problem.
I mean, 2 by 3 times or maybe something like that.
No, no, no. That is your. I think you are saying different thing.
Is
So
it B by?
yeah, yeah. Who is this? Yes, please tell me.
Prajwal.
Yeah, yeah. Please tell me.
So it's B by A.
So B by A. You are saying. Hello.
I'm not sure.
Okay. So okay, actually you are not correct. So basically, pole strength. Does anyone know? So otherwise, I will share the concept. Anyone can try. I mean, who knows this? How it is related? How the pole strength is related to the magnetic field. So what is the definition of pole strength? And so that is related to a magnetic field.
Is it H is equal to mu 0 B?
Sorry, sorry.
H is equal to mu B.
No, B equals to mu H, right?
Ah, yeah, yeah.
So that is relation
Oh,
between the magnetic field and magnetic field intensity. Magnetic field, that is flux density is B, and magnetic field intensity, that is H. So that is the relation between both of them. But I am asking the magnetic pole strength. So you know a magnet, right? That is the north pole and south pole. So there is a strength of the pole. So what's the how do you define the pole strength with respect to the magnetic field of that magnet? That I am asking.
Magnetic field
Hmm.
can be defined by the pole strength. It is the
Hmm.
mu naught times magnetic. It is mu naught times the pole strength due to one pole into pole strength of another pole divided by r square.
Divided by r square. Okay. Mm, okay. I am not sure about that. I mean, okay. So can you just express this in the integral form like integral of magnetic field with respect to surface or line? Can you just express that thing like that? So what I know, the magnetic pole strength.
Inside the
Yeah.
flux.
Yes. Actually,
Okay.
flux of h vector is your pole strength. That is, surface integral of h vector is defined as the pole strength. Okay. So basically, flux by your mu, that is called your pole strength, right? So B dot ds is your flux, right? Who was it?
Yes, sir. B dot ds.
Yes, so that is the flux, but the pole strength is surface integral of h dot ds. So basically, flux by mu, right? So that is the called
Okay.
pole strength. That is like, I mean, what you get in your electrostatics also. That's the flux, I mean, pole charge, that is q by epsilon naught. Like that only. That is just analogous to that. So that you have to know that is the pole strength is defined like that. So there's two things, because this is the one way. If you know this also, you can solve this problem. Okay, try with this. There is another way also you can solve this problem. So if you know this, the pole strength is related to h dot d surface integral of h dot ds, then you can solve this problem, right? Other thing you know already. Then can anyone tell me if this is okay, or am I audible?
Yes, sir. Trying.
Yeah. Please try. So what you have to do, you have to consider current carrying loop with the circumference equals to earth circumference, and for that you know the magnetic field produced by a current carrying loop circular ring, and you know the area. So pole strength equals to, I have already told you, pole strength equals to surface integral of h dot ds, and you know the pole strength given in the question. Also current is given in the form 4 into 10 to the power n. By equating these two, you can get the value of n. So please do that and let me know what is the value of n. So anyone got the answer?
Sir, 35.
Who is this?
Amit.
So how did you get that 35? Can you please tell me?
So I don't know if I'm right.
Okay, you can
I
just
just
tell
did
me.
the
If you are wrong,
formula.
I'll tell. No problem.
I just equated the pole strength.
Hmm.
Okay, I did wrong actually. I equated the pole strength with the that formula, but I
Hmm.
should have done it with equated it with B. So
Equality
I,
h that I have told you, pole strength is basically surface integral of h vector, that is not b. So h. So what is the h vector for current carrying circular loop? Can you just tell me that? That I have already shared in the class just few minutes back.
by 2 hours.
Yes, I by 2r, right? That is the, I mean your radius of the earth, right? Equator, at the equator.
yes.
So I by 2a or 2r, whatever you can say. So and ds, so surface integral, there is basically, it is h times your surface area of the circular ring. So it is pi a square, right? So p equals to I by 2a times pi a square, where a is the radius at the equator. Just put the I value and p value here, and here you know 2 pi a equals to given circumference, that is your earth circumference, 4 into 10 to the power 7. Just use that and you will get the answer. Just now try it. Okay, and let me know the correct answer for this question. So Amit, let me know the correct answer, and others also. So anyone else want to share the answer? Okay, I think okay, let me ask because no one is responding. Okay, Harsh, did you try this question?
Sir, I am trying.
Okay, okay, and others, Amit, you didn't get the answer now.
So I think I messed up, but
Okay, okay,
it's coming 7 now.
okay. Anyone else? Okay, just hold. Let me see this. CC, you tried this question.
I am getting 7. 10 to
Okay,
the power.
okay. Others, okay, okay. Priyanka, Seema, um, okay, I think, okay, I'm going to the solution part now. Just have a look, and okay. Is my screen visible?
It's 14, right?
Who is this?
Amit.
You, so it's not 7, it's 14.
Yes, I don't know. I'm getting different answer.
Okay, okay. No, actual answer is 7. That was correct.
Okay.
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 So I will share two ways to solve this problem. One is little bit lengthy, but maybe it will be helpful for another type of questions also. Okay. So you should know all the things about this. Okay, just give me 1 minute. So one way I have already shared with you, but I will be sharing the one more different way at the first. So it is given that far from the Earth's magnetic field can be approximated as due to a bar magnet of magnetic pole strength P equals to 4 into 10 to the power 14 ampere meter. That is given in the question. Now there is a relation, I mean you can find in some books, that is magnetic dipole moment, that is mu vector, is related to the magnetic pole strength, and that is given by mu equals to P times 2a, where 2a is the your dimension, I mean that is the length of the magnet. So it is applicable for a magnet. So you should know the information because this type of question may be asked, short question. So here A is your Earth's radius in this case. So the schematic will look like this. So you have the Earth, the circular, I mean spherical structure. You can in 2D you can consider is a circle, and at the equator you have a circle through which the current is passing, and due to this the magnetic field lines are produced, so that you can consider it as a magnet, which is directed from the south to north, and it has a length of 2a. That is the diameter of the Earth. Okay. Now assume that the magnetic field is generated by a current carrying loop encircling the magnetic equator. So that is at the equator you have to consider a current carrying loop. The current required to do so is about given in the question, that is 4 times 10 to the power n amps. So I equals to 4 into 10 to the power n amps. We have to find the n here. So magnetic dipole moment due to a current carrying loop is basically given by mu equals to I times the area of the loop, that you know already, right? So just you have to compare the two things, that is the equation 1, that is mu equals to P times 2a, here P is the pole strength, and this is a known expression, that is mu equals to I times pi a square for a current carrying circular loop. Just compare this. So P times 2a equals to I times pi a square. Here for you have to just find the I, that is I equals to P times 2a by pi a square. So if you just cancel out the a here, so you will have a in the denominator, so it will be 2p by pi. So here I is given as 4 into 10 to the power n, p is given as 4 into 10 to the power 14, and 2 pi a is given as 4 into 10 to the power 7. So pi a is your 2 into 10 to the power 7. So just put it here. So we will get 10 to the power n equals to 10 to the power 7. So here you are getting n equals to 7. Is this okay to everyone?
Yes.
Yes,
Okay.
sir.
So this is one of the way where we have used the concept of dipole moment of a magnet. Okay. So the second thing that you can also apply, so that I have already shared with you the concept, that is the definition of the pole strength. Directly you have to use the definition of the pole strength here. So your according to definition of pole strength, you have the pole strength equals to surface integral of H vector, that is magnetic field intensity, times ds, that is the surface integral, right? So now H vector due to a current carrying circular loop is given by H vector equals to I by 2a along the z cap direction, that is from south to north direction. Here you have considered z cap direction along this. So your pole strength will be this H vector times your area of the circular loop, that because it is a surface integral, right? So I by 2a times pi a square, so it will give p equals to I times pi a divided by 2 equals, so you can write it as I by 4 times 2 pi a, because 2 pi is circumference of the earth, so that is given as 4 into 10 to the power 7 meter. Here you put the I value, that is 4 into 10 to the power n, p value is 4 into 10 to the power 14. Just cancel all the 4's from here, so we will get 10 to the power n equals to 10 to the power 7. From here also you are getting n equals to 7. So your correct value for the n is 7. So is the two different methods are okay? Is there any confusion?
Sir, can we do it dimensionally also? Is that way also correct?
In this case you are getting correct, obviously, because there's the ratio of those two thing. Luckily you will get the correct answer, but if you have to find the
Yes, sir.
proper number, then you are not correct, that I would say. In this case you are lucky, actually. You got
Yes,
my
sir. But
point?
actually, we are getting just an estimate here, sir,
Yes, yes,
because
yes.
it is given 4 into 10 10 to the power n.
So basically your current
So
is the
yeah.
ratio, dimensionally it is the ratio of the pole strength and your the radius, or you can say circumference, right? So but the actual, for the actual number you have to do it in a proper, but dimensionally it is correct,
Yes,
obviously.
sir. But in I think these carry no negative marks in paper, so we can take the risk.
You can take the risk. You can take the risk.
Yeah.
But yeah, that I have said already. If it is asked in your MCQ questions, that is you have to find the exact answer, that is 4 times 10 to the
Yes.
power 7, then you have to do it, right?
Yes.
That's the thing. Yeah. So, okay. Anyone else? Anything you need clarification for this? Okay. Okay, so let me ask people.
Understood, sir.
Okay, okay, fine. So, okay. Anuj, is it clear, right?
Yes, sir.
Okay. Sisi, is it clear?
Yes, sir.
Okay, okay. And Amit, is it now clear to you, because
Yes, sir.
you're getting puzzled? Okay, fine. Okay, and okay, fine. So I'll move to the last question. That is a very easy question. Then we can stop. Okay. So okay. So this is a question from GATE Physics paper 2020. This is a NAT question having 1 mark. This is from solid state physics. So here the two-dimensional crystal structure is given. You can see. So the question is the number of distinct ways the primitive unit cell can be constructed for the two-dimensional lattice as shown in the figure. So this is the structure it is given. So you have to construct. You have to tell me how, in how many ways you can construct the primitive unit cell from this two-dimensional structure. So can anyone tell me what is primitive unit cell? Who has studied the solid state physics or crystal structure?
A
So
unit
I
cell which contain only one atom is called primitive unit cell.
Effectively one atom. Yeah, that's one definition. And more precisely, there is. Can you tell me more precisely? That is correct actually. Effectively, you will have a one atom per unit cell. So how can you achieve that one atom per unit cell? How will you construct the unit cell so that you will get the one atom per unit cell?
We can make a square around.
Okay,
It is
okay,
one way.
okay.
And we can also construct the corners, take
Hmm.
the four corners and make a primitive cell.
Right, right. So, okay, that's correct actually. That's correct. So, can you just tell me how many ways you can construct in this case? That's correct. The concept is okay. Okay, just think about it. I will give you 2-3 minutes. Just draw the 2D structure in your copy and try to construct the how many ways you can construct the primitive cell unit cell in this case by knowing the definition of the primitive unit cell.
So three ways.
3 ways you are saying, right?
Yes, sir. Because
Okay.
we have to keep in mind that whatever structure we are trying, there should be no gap in between any
Right.
of the
The periodicity
structure.
should be maintained, right? So that you
Yes,
will
yes.
not have any gap between the structure. It should be continuous, right? So you are getting three. Okay. Hmm. Okay. Let me see other people what they are getting. Then I'll share. Okay. I'll tell. Okay. Just think about it. I mean, I am not saying it is correct or it is wrong. Just think about it. Okay.
Okay, sir.
Sir, do we have atoms at the corner only in primitive unit cell, or do we have it in between?
Yeah, actually, more formal way, what we usually consider, that is we have to consider the atoms at the corners. Okay, so that is the usual way to construct the primitive unit cell. But there is, when some books also shows that if you consider a atom at the center of this square, but there is no atoms at the corners. But most of the most of the places I have found that that's not the formal way. The formal way is you have to consider the atoms at the corners so that you will get the
Okay, sir.
effective number of atoms 1. That's the definition of
Okay, sir.
primitive unit cell. So please use that concept because I am also following that convention here.
Okay, sir.
But both the ways are correct. You will get the same answer. So that's not the fact. But I think in this case, if you consider the lattice parameter A, then how will
So
you,
only triangular,
huh?
only triangular ones.
Only triangular ones. Okay. That means you are connecting 3 atoms here.
Yes.
Okay. Just let me check once. Okay. Just let me check once. That's but your lattice parameter is this is not A, right? You are given the
Okay.
lattice parameter A this and this direction not this direction A, so that should be integer multiple of your A,
Yes.
or okay. Just let me think once. Okay, just let me think. That's not the point. Just let me think here. No, it can be fractional part of A also. That's not the problem. Not integer every time. Triangular one is also okay. But is that the effective number of atoms are 1 in that case? If you consider this, so you have to have 4. So 1/4, 1/4. No, then it is not correct, right? You will have effective number of atoms 3/4 in this in itself if you consider triangular. Who was this? Was telling me.
Sir,
Yes, sir.
So then effective number of atoms will be 1. No, no, not right.
No, no.
So that cannot be here. That cannot be.
So it
So
looks simple, but it is not so.
okay, just think for 1-2 minutes last. So then I will go to the answer so that you can understand how many ways. So I have done the solution, so I know how to do that. So basically it depends how can you good imagine in a good way in this case. That's the thing, it matters. Crystal structure is like, it depends on how can you visualize these things in a good way. Okay, there are lots of concept, I know. So try to find the trinity unit cell by connecting 4 points. Okay, not 3 points, it will not be possible in this case at least, I know, because you have seen already, right? You have tried, it is not possible. So how many ways you can connect the four atoms such that you will get the effective number of atoms 1 in each unit cell. Okay, so if you can construct that, then you will get the number of ways to do that, and you will get the number of possible primitive unit cell in this case. Okay, so will I go to the solution, or you want to try? Anyone to try for 1 minute again, or will I go to the solution? Okay, I'll ask people so what they are getting, at least the number. Okay, anyone else? Anyone?
Sir,
sir,
I got 5.
Acha, who got 5? MD Imtiaz, right?
Yes,
Muhammad
yes.
Imtiaz. Okay. Okay, so okay, I don't know how can you share your solution. Okay, anyway, I will be sharing, then you can tell if it is different from me. Okay. Okay, anyone else? Amit, Anuj, Harsh. Acha, okay. This is 5. Acha. Anyone else getting anything else or 5? Okay. Let me go to the solution then. Okay. Okay. So just for your the recapitulation of the primitive unit cell. So primitive unit cell is the smallest volume cell possible in the lattice structure. All the lattice points belonging to a primitive unit cell lie at its corner. That's the convention. Therefore, the effective number of lattice points in a primitive unit cell is 1. Now, let us see the number of distinct ways of constructing the primitive unit cell for 2D lattice. There is no hardcore rule, just you have to. So, the answer is 5. Okay. So, the possible ways to construct the 5 primitive unit cell in 2D structure is this. So, first you can construct like this. This is one way. Okay. Second way, you can just connect these 4 points. Third way is you can connect this way. So basically this structure is like rotated by 90 degree. So one of this is this way. So this looks like similar but not, because your angle of this and this is not same, and this is just This is the fifth one. Fifth possibility is like this. There is no hardcore rule. You have to just construct in several ways so that it becomes a primitive unit cell. So, is the construction is understandable to everyone?
Sir, I thought it this way, but
Okay.
in the at the corners, if we continue like this, then there will be gaps,
For
right?
how?
Means after you have written the structure with the number two, then how can we continue? I mean, we have to consider this infinitely long, so
Yeah,
we can.
yeah. So
Okay.
you have this, then you can consider here this also, right? Same structure. So all the lattice points will be covered. So I have not drawn here. So if you can consider, if you consider this two, okay, possibility two, then you can just, if you consider your origin here, you can have that displacement vector or R vector, which is called in lattice structure. So you can just fractional. So your A is this, right? Okay, let me check one thing. Your A is this, so your A is this, so it will be some angle that will be your maybe 60 degree, not 60 degree, right? What will be the angle this? Can you tell me the angle here in this case? If it is a triangular, so this is 60 degree, 120, this should be 120 degree, right? So this is a triangular, right? This case, so it is a 120 degree. Okay. So yeah, so what's the problem? Can you please ask me again?
I mean, now it is clear, but I was thinking that we have to consider only these points, whatever is given.
Oh,
I
I
didn't.
mean, the question you are saying these points only?
Yes, yes, yes. I didn't think
Oh, no,
about
no, 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 no. This was just a
Yes, sir, same
schematic.
here.
this infinitely.
Oh, no, 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 no. So if it is given a lattice structure, you have to consider always it as a infinite lattice structure.
Okay, then
That's
I've
not a problem.
thought like this, but then eliminated this.
Okay. But these are the only possible five ways according to definition of primitive unit cell. I think other than that, you will get the similar thing. I mean, if you want to construct other thing. Okay. Now,
Okay, sir.
yeah, yeah. Any question from anyone?
Excuse me, sir.
Yeah, yeah, yeah. Who is
Uh,
this?
why cannot we construct more than five primitive unit cell? I am not getting. Can you repeat?
So okay, so see, other than that, how will what will you get? You can get, okay, I will just show you by laser pointer. Okay, how can I draw here? I don't have that uh, I mean opportunity to draw here now. Okay, so you can get a unit cell like this, right? By connecting this point, this point, this point, this point, right? You can, this is also a unit cell, right? Are you getting my point?
Y- Yes, sir.
Yes,
But
but the
there
effective
the effective
number
number of atoms are 2 here, because at the
two.
middle it is coming 1, and at the fourth it will have a contribution of 1/4. So this is not a this is a unit cell, that not a primitive unit cell. Primitive unit cell will have always the effective number of atoms is 1. So that's the condition you have already. So by knowing that condition, you can construct the primitive unit cell only in these 5 ways. That's the thing I am saying.
Sir, can you please explain the fourth structure again?
Fourth structure again means, okay, so this is how you can connect the 4 points. So in, I mean, you got the point, right? Here the, in this fourth structure, the effective number of atoms are 1. You got this point, right?
Yes, yes, I got that.
So that's the only thing. So I mean, what's the problem here? Can you please ask me then?
The 1 and 4 is identical to me.
No, not identical. That's the thing, not identical. So basically, your, if you see your, like, if it is your A, right? So A, so this is A here, this is A here, that's the same. But if you just express your lattice vector B in this case, and in this case, there is a not same, because if you express the in terms of x cap and y cap, that is not same here, right? That is not same actually. It looks like same, but if you construct mathematically the lattice vectors, then that is not same in this case.
Yeah, it is a horizontal mirror image.
Yes, yes, mirror image, but that is not same, right? There's a mirror image
Yes,
of this,
yes,
obviously.
mirror images are not same.
Not same. Yeah. That's the thing. Okay, any confusion? Also, this is the same thing. What? Who told that thing? Mirror image. What is your name?
Sir Amit.
Amit. Amit. Okay. Yeah. So this is the same thing. Is
Just with 3 and 5.
right. So all the possibilities you have to consider here. So they are symmetry, mirror symmetry in this case, but those are not same. Okay. Fine.
Sir, where can I study this mirror image concept? I want to study this
Oh,
more.
so this thing you will find in the crystal structure. So group point group symmetry in that part. So I think in the bachelor's course we don't study it much. I don't know. I mean, in our case, I studied little bit, but in masters, I think you will study these things well. So the books Astromarmin, it has been discussed very well that we have studied in our masters, and I think there are several books in the masters category, so you can find that thing, that point group symmetry, mirror symmetry, translational symmetry, rotational symmetry, all the things has been discussed in the crystal structure. Okay.
Okay, sir. Thank you.
Yeah, so the symmetry part you have to study in that case in crystal structure. That's the very interesting thing actually to understand. Okay. And that will be also helpful to understand determining how people determine the crystal structure from the XRD data, because it's not so easy to find the crystal structure if you have the raw XRD, that is the extra diffraction data of a sample, because in that case you have to apply these symmetry concepts to construct the exact crystal structure. Usually the softwares do this kind of things, this symmetry consideration and everything. So anyway, for the basics you can study these things, and if you are working in the future these things, the crystal structure and this thing, then you will understand it better. Okay. Okay guys, I think any confusion, so that last answer is 5 for this question, and thank you then.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Yeah.
Thank you, sir.
Thank you guys. Good night.
Thank you, sir.
Sir,
Yeah.
sir, can you please share your email ID, because I have completed my master's in
Okay.
CMP only.
Okay.
So, and I am into means
Okay.
I want to do experimental CMP and research.
Okay, I am sharing my. Just wait. Just
Okay.
see in the chat box.
Okay, sir. Thank you, sir.
Okay. Hmm. Okay, this is my email ID. And one more thing, I will be sharing my YouTube channel. Please subscribe it to guys. Just wait for a minute.
Sir, do we have recorded session of this lecture?
This will be shared. This session will be shared. Okay, just give me 1 minute. Okay, hold for 1 minute. I'll be sharing one thing that you can see for the past session. Just it is very slow. Okay. Okay. So acha, Harish, are you saying something? I am really confusing. Repeat. That means I didn't get you. So this is my YouTube channel. So here I will be just sharing the solution part, not the live session. And the live session will be, I'll share with the NPTEL team. They will share this with you guys in the portal. Okay. Because in YouTube it is very difficult to, I mean, it's time consuming to upload the whole session. So I'll just upload the solution part in this case. Okay, Harish, I didn't get you. Sir, my mic. Okay. Okay, anyway, you can follow my YouTube channel. Please subscribe to it if you like it. And okay. Okay, guys, thank you.
Thank
Okay, and I have given my mail ID, so if you have any confusion, you can send me a mail also. I'll reply to that, no problem. Okay.
Thank you, sir.
Thank you, guys. Bye
Thank you,
bye.
sir.
Bye bye.
Bye bye. Good night.
Good night.